All right, so for this next one, this one is 5 times the exponential e, which remember is a number raised to 5 raised to the 5x is equal to 20. So remember, e is approximately 2.72-ish. It's kind of like pi, but it's called Euler's number, named after the French mathematician Euler. But we just leave it as e. Anyways, so what I want to do is I'm probably gonna if I can make it look like this, then I can convert it to a log and enter it in a calculator and get the answer. Okay. So let's do that. I noticed that I can divide by 5 both sides. So my goal is to kind of figure out a way to get x by itself, sort of, but it's a little different here. So what I'm going to do is move this 5 away from the e, because then I have just a base, right? I really want to get just the base by itself with the exponent, and then get, all the other stuff over here. And then I can convert it to a log. So 5 divided by 5 is 1. 1 times e to the 5x is equal to 20 divided by 5, which is 4. So in this particular case, my base is Euler's number e. My exponent, which is n, is 5x. And then my m term is 4. So I'm using this notation here. B raised to the n equals m. So then I'm going to do the log base b of m equals n. Okay, so in other words, I'm going to say log base e of 5x equals 4. Okay. So log base, no, I did that backwards. It's log base 4. Log base of, I did that backwards. Hold on a second. I'm trying to think about something, and it's log base e of 4 equals 5x. So this is kind of confusing. But it's a number. Okay. I know what the number is, but I want you guys to figure out along with me. So basically what I'm going to do here, this is log base 4. So I'm going to enter in log. Oops, where's my... I keep saying the wrong thing. So it's log base e. Which is, we're going to put e to the 1 of 4. And so we get this decimal approximation, which is the 1 point, let's just say 1.39. So then this becomes 1.39 is approximately equal to 5x. So then we divide both sides by 5x. And I should get 0.28 equals x. So I'm going to